I'm Ian Gilbert from HackerScouts Guild 10 in St. Louis, and we're going to be explaining pulse width modulation. Now what this is, imagine a strobe light. It flashes on and off very quickly. Now if you take that process and speed it up to where it's flashing on and off even quicker, like that, it'll look like it's on, say, half the time. If it is on half the time and off half the time, it'll appear to be half as bright. This is because, say with this LED, this is because your brain can't process the individual flashes quickly enough to see each individual flash, so it sort of blends it together as a slightly dimmer flash. This also works for different percentages. Say if you had it on 75% of the time, or 25% of the time, it would appear 75% as bright or 25% as bright, depending on what you have the pulse width modulation set to. Here we actually do have a setup where the LED is cycling how big of a delay the pulse width modulation is set to. So it appears to be slowly getting brighter and then dimmer based on that. When in actuality what it's doing is it's just flashing quicker and slower.
Hey, I'm Jack from HackerScouts Guild 10, and I'm here to explain the oscilloscope. If you didn't quite get pulse width modulation yet, this will help you. Basically, this is an oscilloscope. It gives you a visual representation of what is happening here. As Ian showed you, or told you, pulse width modulation is when a light flashes on and off extremely fast, depending on how bright you want the LED to be. This is a visual representation of that. As you can see, there's a wave here. The bottom here represents time, and on the side that represents voltage. When the bar over here is longer, it means that the light over here is brighter. When the bar on top is shorter, it means the light is dimmer. It's basically just representing how long the light goes on versus off, and the time is this is a measurement of 200 nanoseconds, and that's about it in essence.